Hello everyone, welcome back to Let's Crack J in English, the channel of Unacademy. And let me start with my introduction. I am Jeetendra Dixit. I did my BTech from IIT Kanpur, and I have been working with various national level institutes for 11 years. So I teach mathematics, and we were doing sequence and series, right? So I have already covered arithmetic and geometric progressions, their summations of series, and journal term based questions, right? And their properties. So today, what are we going to do? We are going to practice some questions of AP and GP altogether. So this is a practice session of AP and GP. And then after that, we'll go ahead in the topic. Like we'll study HP, arithmetical geometric progression, and some method of subtraction and telescoping series, sigma, AMGM inequalities, and means. All right. So all these things will be covered in upcoming lectures. Let's practice some questions, some good questions today of APGP. All right. So before the beginning, let me tell you about the Unacademy subscription. So as you guys know, that Unacademy is India's largest online learning platform. All top educators are teaching on Unacademy. So first, let me tell you the things. If you are preparing for IIT-JEE and you get the subscription, then what are the things you can access on this platform? So first, you can access the daily live sessions of all the top educators who are teaching on Unacademy. All there's no restriction. You can follow any educator and you can watch their daily live sessions. Their schedule will be everything is pre-planned, structured, so you can see the schedule of all the upcoming lectures in well advance when you plan your sessions like that. Okay, so every educator's schedule you will be able to see on the platform, and then accordingly you can plan your sessions. You can follow educators of your choice, or you can join a course as well. Every week there are new courses are starting, so you can join a new course. You can also watch their offline recorded lectures. How offline? You can download the recorded lectures and you can watch them offline, right? Second, during the live session, you can interact with your educator. Interaction, that means you can ask your doubts. If you're having any problem, you can just write to your educator. He will immediately answer because chat is going on. So that makes the session very interactive. You can send your images for doubts. You can participate in the poll if educator is giving you a question with options. You can participate in the poll. Quiz feature is also there, so you can attend unlimited quizzes. Okay, and quizzes are free as well, right, on the platform, along with the special classes. Now, let me tell you about the special classes. What is the special in special classes? That these are free for everyone on this platform. All right, I mean everyone who just you need to download the Unacademy's learning app and just make your account. After making the account, you can watch unlimited special classes by all the educators who are teaching on the platform. They take a few sessions as a special classes, and every day a lot of special classes are going on. So just attend unlimited special classes without getting the subscription. That means you don't need to pay anything, and by attending these special classes you will come to know the feel of the platform. You will get to know how to ask your doubts, how to participate in the poll, right? So you'll come to know how interactive these sessions are. All right, so just go and attend the session to not miss anyone. All right, so this was about the unlimited access you get once you're subscribed and even without the subscription. All right, now this Unacademy's learning app you can download from Play Store, and after downloading you can subscribe for 1, 3, 6, 12, and 24 months. 12 months package is 38,500, and after 10% discount you'll have to pay only 34,650, and 24 months price is 56,000 and 56,000 without inclusive of all taxes but without discount. So these two packages I am telling you because these are the economically better packages in which average per month price is low compared to any three above these two. I mean, it's not advisable to go for 3 months because I know certainly you are going to extend it, right? So you can attend unlimited special classes and then you can decide, right? All the educators take special classes, so you will be able to watch their sessions. All right, so use my code JEET1 to get instant 10% discount. All right, so use this code and get 10% discount. So, all right, I hope it is clear. Now, let's begin today's session. All right, so let's begin today's session. Here it is. So we are going to discuss, this is the first problem. We have already done AP and GP. I'll give you time to solve the problems. So you first read the problem, try to find the answer, write the answer in comment box, and then I'll start discussion. All right. This is the first problem. You need to find the sum of this series. I don't know which series is this. You need to figure it out. So you figure it out. Try it, try it. I'll discuss in 2 minutes. You try it first. All right, so done, guys. I hope you have done, you have completed. Let me solve it then. So this is not AP, this is not GP, right? So then what to do? Let me rewrite it. It is x plus 1 upon x the whole square plus it is x square plus 1 upon x square the whole square, sorry, plus this is x cube plus 1 upon x cube the whole square and so on. So if you would have this x plus, if square is not there, then you would have x square x cube, first term of each bracket, they are in GP, right? And second terms of each bracket, they are also forming a GP separately, right? So but it's because of this square there's a problem. So what we need to do is first expand it, so you'll get squares of squares. So there's no problem if you are squaring the terms of a GP, they will remain in GP. This is a property, right? So using that, we can write this x square plus 1 upon x square. So all the terms of each and every factor will get squared. So GP, which I have just shown you, the first term of all the factors in second term. So they will remain in GP even after getting squared. And you'll get one extra term 2ab, which is a constant. So no problem in adding constant for any number of times. This is now x raised to 4 plus 1 upon x raised to 4 plus 2. This is now x raised to 6 plus 1 upon x raised to 6 plus 2 and so on. Alright. So just add them. Take this first term first together. So it is going to be, your first series is going to be x square plus x raised to 4 plus x raised to 6 and so on, 10 terms, 10 terms. Then the next series is going to be this 1 upon x square plus 1 upon x raised to 4 plus 1 upon x raised to 6 and so on, 10 terms. All right. And then one more term, this 2 plus 2 plus 2 plus 2, right? How many times? 10 times. Okay. So let's apply the formula. This first term is going to be this is going to be 1 upon x square. Oh, oops, yeah. All right, removed. So this is your first term into common ratio is x square minus 1 upon, sorry, number of terms, so it will make, that will make it 20, x square raised to 10, so that will make it x raised to 20 divided by x square minus 1 plus, now in this first term is 1 upon x square and then common ratio, so 1 minus, let's write 1 minus 1 upon common ratio raised to 10, number of terms 10. Let me write it properly. All right, like this. Divided by 1 minus 1 upon x square. Plus 2 plus 2 plus 2, 10 times is nothing but 10 into 2. So this is 10 into 2. Okay, so just we need to simplify it, and we'll club these two terms. 20 you can see is there in every option. So 20 is already there. So let's write this 20 first plus these two terms. So first term, there's nothing to simplify. X square x raised to 20 minus 1 upon x square minus 1 plus, if we take x raised to 10 common, it is LCM basically, so it is x raised to 20. Uh, this is x raised to 20. X raised to 20 minus 1 into x square, and if you take LCM, then x square will get cancelled. So it is going to be x square minus 1 x raised to 20 into x square minus 1. Alright, so finally from first and second term take common whatever you are getting common. So x raised to 20 minus 1 is common, x square minus 1 is common. Now it is going to be x square plus 1 upon x raised to 20 plus 20. Now if you take LCM, it is going to be x raised to 20 minus 1 upon x square minus 1, and it is going to be x raised to 22 plus 1 divided by x raised to 20. So which option is correct? See which option is correct. So yes, obviously option A is correct. So this was the correct answer. I hope it is clear. That's a very good problem. All right. Now let's move to another one. These two APs are given. We need to find the number of identical terms. A similar question was there in JEE Main this year. In September's JEE Main, 3rd September first paper, there was one question of sequence and series in which two arithmetic progressions were given, and we needed to find one common term, number of common terms. Yeah, so it's an important point, important question. Try this. Common term occurs at the gap of LCM of common differences of both the arithmetic progressions. So you can see the first arithmetic progression has common difference 3, and the second arithmetic progression has common difference 2. That means you just need to figure out the first common term first of all. So if you get first common term, which you can see is given actually in the question, it is 5. The next common term will be after the gap of LCM of 3 and 2, that is 6. That means next common term is going to be 11. If you see 11 is visible in the first sequence, and if you write some more terms of the second sequence, you'll get 11. 7, then 9, then 11. You can see 11 is common. So every common term is going to be at the gap of LCM of, correct? So common difference of first AP is equal to D1 is equal to 3, and common difference of second AP is D2. Let's take it D2, this which is given 2, and the LCM of 2 and 3 is equal to 6. So common term of both the APs will occur at the gap of 6. So Every sixth term will be common. You just need to find. And first common term is, and first common term is 5. So now this there's another AP of common difference 6 with first term 5 is going to be a common AP, common terms, AP of common terms. But where are we going to end this AP? That is an important point. Where are we going to end? So we need to find the upper limit, okay? So AP, so this common terms, common terms are, let me write it, 5, then we know that 6 is the common difference, so 11, then 17, right? And then keep adding it, 23, and so on. But where to end? What is the last common term? To know that, you need to write the last term of this and last term of this, and obviously the last common term will be smaller than the smaller of these two, smaller last term of these two, right? So whichever series, whichever sequence has the last term smaller, the our last common term will be less than that only, right? So let's write these term, last term. So last term of this has 60 terms. So last term is 2 plus 60 minus 1, so 59 into D. D is what? 3. So it is going to be 170, uh, 179. Yeah. 179. And what is the last term? Last term of this is going to be 3 plus 49 into D. D is 2. Oh, so obviously this is going to be smaller because common difference is low and the first term and number of terms are also 50. So this is going to be the smaller number. So what is this? 50 into 2, 100 minus 298 to 101. So 101 is the upper limit of this second series. So common term cannot exceed. That means Tn should be less than 101. Now let's solve it. What is Tn? Let's take nth term is the last common term. So that should be less than 101. That this is what we have got. And we'll use this to find the greatest value of n. Alright. So what is the first term? First term is 5 plus n minus 1 into d is 6. I'm writing the nth term of this sequence. This is less than 101. So I'll get n minus 1 into 6 is less than, subtract 5. If you subtract 5, it is going to be 96, and then divide by 6. So n minus 1 is less than 96 divided by 6. So 96 divided by 6 is what? 48. Ah, less than or equal to, actually equality also you can put. Maybe 101 might also be common the last term, or maybe so if you are getting n is equal to integer, then that is true. So actually, yeah, actually you are getting an integer, yeah. So this is uh, size 16. So n is, you are getting get less than equal to 16. So 16 terms are common. What if you would have got 16.5? Then also 16 terms will be common because 16.5 is not an integer, all right? Then it is less than or equal to less than or equal to 16.5. So you need to take the greatest integer, all right? So greatest integer less than or equal to 16.5 is 16, all right? 16, because it is 16, so 16 is the answer. If you see the 16th term, then 16th term will be 101 of this sequence. If you write the 16th term of this sequence, then that will be common, and you can check it. 101 is common in both. So what is the answer? Answer is B. I hope it is clear. I hope it is clear. B is the answer. So this was a very good question. Now try this. Oh, very interesting, very interesting. It's a tricky one. Not difficult at all, very easy. Try this. Getting anything in this? Now, this is not AP, not GP. Then what is this random sequence? 1, 2, 3, 4, 5 up to 8 is okay. 8 is also fine because 1, 2, 3, 4, 5, yeah, they are forming AP. But 8, suddenly 8, common difference became 3, and then 7, a number less than 8. And then fifth, 16 again, and then again 9. Oh, what is this? I hope you are catching it. I hope you are getting it. I'll give you 1 more minute. Think about it, try to get the answer. By then, let me rewrite this. Got it, guys? I hope you have got it. Say, it is basically a summation of two series. Which two? If you look at first, third, fifth, seventh, fifth. I mean, first, third, fifth, then seventh, as well as ninth. So they are forming first. First term is first term is one. Then this. Look at this term. Let me underline this, 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 and this. They are forming a AP with common difference too, right? I'm skipping one term always. Just skip term between any two consecutive, first and third, third and fifth, fifth and seventh. Skip this eventh place terms, you can say. And what are these terms written on even places? They see these, look at these numbers. Are they also forming some other known series? Yes, actually, yes. Which one? They are forming a GP, 2, 4, 8, 8, 16. So these terms are forming a GP. So let's separate this GP and AP. So AP is going to be 1 plus 3 plus 5 plus 7 plus 9 and so on. How many terms? Total we have 40 terms. You can see it here, 40 terms. So this will have 20 terms and 20 terms will go in GP. So GP is 2 plus 4 plus 8 plus 16 plus so on. All right, this is a GP. Okay, so find the sum of this AB. This is going to be 20 by 2, twice of A plus n minus 1. So 20 minus 1 into D is 2. All right, this is the sum of AP, and sum of GP is A. So 2 into a raised to, so 2 r raised to n, so that is 2 raised to number of terms 20 minus 1 divided by 2 minus 1. Done, we are finished. So you can cancel this 2, 2, 2, and this will be 20 minus 1 plus 1, so this will be 20. So 20 into 20, 20 square, plus this is going to be 2 into 20, 2 raised to 20, so 2 raised to 21, minus 2, divided by 1. So this is 400 minus 2, which can be written as 398 plus 2 raised to 21. So this is your answer. This is the correct answer. I hope it is clear. Now let's do another problem. Oh, wow. Very good problem again. I'll give you time to solve it. Very good and easy problem, not difficult. Very, very good problem. Try this one. I'll give you 2 minutes. All right, so let's do it. The sum of first 10 terms is called S1. So let me write one GP and I'll show you that this is very, very easy problem. So first term AR plus AR square and so on up to AR raised to 9. This is the sum of first 10 terms. This is given S1. This is given S1. And if you write the next 10 terms, that will start from AR raised to 10 plus AR raised to 11 and so on. This is up to AR raised to up to 20th term, right? 11th to 20th. So this will be ending at A raised to 19. AR raised to 19. So this is your S2. Can you notice something? If you R raised to 10 is common in this, all right? So if you take R raised to 10 common, see, right, if you write S2 is equal to, take R raised to 10 common, what is this going to be? It is A plus AR square and so on. Just write the last term, it is AR raised to 9. Can you see this is nothing but S1? That means you don't need to write the summation of S1 and S2 directly, then you can figure it out. So it was very easy. So R raised to 10, it is now S1, this is now S2. So R raised to 10 is equal to S2 upon S1. Then you can write R is equal to, okay, whenever you are taking eventh root, you'll have to put plus minus of 10th root of S2 upon S1, okay? Like you take a square root, you put plus minus, you take fourth root, you put plus minus, you take sixth root, you put plus minus. And similarly, any eventh root, you'll have to put plus minus, okay? So in this also, you'll write R is equal to plus minus of S2 upon S1. I'll repeat again what I have done. Let me explain it again. Sum of first 10 terms was given S1. Okay, so I've written first to 10th term sum and then 11th to 20th term. All right, 11th to 20th term. This is the 11th term, A plus A into R raised to 10, and same sequence, same first term, same common ratio, and this is the 20th term. So 11th to 20 sum was given S2. All right, we needed to find R in terms of S1 and S2. So I wrote S2, I started from this expression, okay. I took common, whatever was common, so common you can say was R raised to 10, but not I have not taken common, I just took R raised to 10 common. So after taking R raised to 10 common, this was the remaining inside the brackets, and I can see then this is nothing but S1, this first 10 terms. So I have written this is equal to S1. Now it is R raised to 10 into S1. So I've got R raised to 10 is S2 upon S1. And then I wrote R is equal to 10th root of S2 upon S1 with plus minus sign. All right. So whenever you are taking even root, you'll have to put plus minus sign. So I hope this problem is clear. Now let's begin the next one. Again, this is a good problem, but we did one such problem. We have done one such problem today. All right, so let's do it. I suppose you have completed it. So this directly, if you see, this is not a GP, but as we did one problem in which you were having binomial terms, then you split first term of the binomial expression in second. In this also you can do the same. You can see this is root x into root a, this is root x into root ab, this is root x into root a into b. So you can see root b is multiplying, right, in every previous term. So let's write first term of each bracket root x into root a plus root x into root ab, then plus root x into root a into b, plus so on. All right, this is the first series. Now let me write the second one. So second is going to be x plus this is going to be xy, x root y, sorry, uh, mm, x root y. Let me write it clearly. So the second term is going to be x root y plus next is going to be yx, that means x into y and so on. So in this you can see common ratio of this is nothing but root y and common ratio of this is nothing but root b, right? So now you can see these two, we have splitted these two into two GPs, and common ratio because b is less than 1, so this quantity is less than 1, this quantity is less than 1. All right. So let's write the sum of first. So it is going to be root of xa upon 1 minus common ratio is root b, and this is first term. First term of this is what, x upon 1 minus common ratio root y. All right. So this is your answer. Check which one is your answer. D option. So D is the correct option. This was pretty simple. Now let's move to another one. Solve it. This is again a pretty simple problem, not difficult. Either you can start from left hand side or you can start from right hand side as well. So let me solve it. I'll start from right hand side, all right? So, so if I start from right hand side, then I can multiply it by 1 minus r and divide it by 1 minus r, all right? And let's write the remaining factors as it is. So why am I doing so? Because after doing so it is going to be triggered and every pair will be combined. It will using the formula of a minus b a plus b. So this is going to be 1 minus r square and then 1 plus r square and then rest of the factors divided by 1 minus r. Then it is going to be, this will be clubbed, 1 minus r, a minus b a plus b, so a square minus b square. So 1 minus r raised to 4 and then 1 plus r raised to 4 and 1 plus r raised to 6 divided by 1 minus r. And then again this will be clubbed, so it is going to be 1 minus r raised to 8 into 1 plus r raised to 8 divided by 1 minus r. Now this 1 a minus b a plus b is again 1 minus r raised to 16 divided by 1 minus r. So it was so simple, right? Now you can start from left hand side and apply the formula of GP. So 1 plus r square ends up to r raised to n is 1 into 1 minus common ratio to the power number of terms n plus 1. Number of terms are n plus 1 because we are starting from r raised to 0. This is nothing but r raised to 0 divided by 1 minus r. Now compare this 1 and 2. Okay, equate them. So you'll get 1 minus r raised to 16 divided by 1 minus r is equal to 1 minus r raised to n plus 1 upon 1 minus r. So after comparing, you can get n plus 1 is equal to 16. It was so simple, right? Then n is equal to 15 is your answer. Quite easily done. Now this is our next problem. It's a very, very, very good problem. Solve it. Done. I'll tell you one trick to solve it, and it is going to be very interesting. You can do this in just a minute or even 30 seconds, but you need to understand something. So I'll explain it properly, then you can apply that trick. It's not a trick, it's a property of AP. If you apply that property, then you can do it in that just 30 seconds, even less than that. I mean, anyone can do it in just less than 30 seconds. And now that depends on your understanding. If you understand it properly and you can use it properly, then you can reduce your time even from 30 seconds. All right, I'll tell you the trick. I'll tell you the property. So property is this. Let me give you the property first. Um, Suppose these are your numbers in AP: A1, A2, A3, A4, A5, A6, A7, A8, A9, and so on. If you add these two terms, okay, let's add. If you add first two terms, say two terms you are clubbing S1, the next two terms S2, the next two terms S3. This has nothing to do with this question, okay? My notations are different. So S1 is sum of first two terms, S2 is sum of next two terms, S3 is sum of next two terms, and then S4 is sum of next two terms, and so on. Then S1, S2, S3, then S1, S2, S3 also form an AP. That means these terms S1, S2, S3 also form an AP. But you need to add two terms. It should not be like two terms, then three terms, then two terms, right? Two terms, first two terms, the next two terms, the next two terms, the next two terms. Some will be. See, in this, it is, you can clearly see it is a plus 2a plus d. It is also 2a plus, but d and d. So how many extra d's will come? So 2x, you can see this is a plus d, a plus. Okay, or there's another explanation. Let me give that explanation first. Just look at the first six terms, okay? First six terms. I'll explain from first six terms. A1 plus A6 is equal to A2 plus A5, right? And that is equal to A3 plus A4. So if I write twice of A3 plus A4, then you can write this is equal to A2 plus A5 is plus A1 plus A6, because this and this and this, these are equal, right? So using that property, you can say, yeah, twice of S2 is equal to S1 plus S3. That means S1, S2, S3 are in AP. Similarly, S2, S3, S4 are in AP. Similarly, S3, S4, S5 are in AP. That means S1, S2, S3, S4, S5 are in AP. Okay. By applying that logic, in fact, you can club A1 plus A2 plus A3 plus so on up to AN. You can club three terms also. I mean, let me club three terms here, then we can generalize it. So if you take first three terms, then you take next three terms, then you take next three terms. If you call this S1, this is S2, this is S3, then you can write S1, S2 and S3 are in AP. Okay. Similarly, you can take four terms, then next four terms, then sum of next four terms, then sum of next four terms. They will also form an AP. Okay. So if you are taking n terms, then an plus 1 to a2n, next n terms, and then a2n plus 1 to a3n, all right? And then next n terms. So they will also, so if this is your x, what shall I write? Okay, what is given? So they are forming. Let's not take this s this time. Let's take this b1. Let's take this b2, and let's take this b3. All right. So B1, B2, B3 are in AP. That is the point. So I hope you got the point. Now we are going to use it. Now what is given? Now this was the explanation. I was not solving the question. This was the property I was explaining. Now we are going to solve the question. Now we know the property that sum of first n terms, sum of next n terms, and sum of next n terms are forming an AP, and we are going to use this in this question. Then how to use this? First of all, he's saying that sum of first n terms of an AP is half the sum of next n terms. That means if b1 is equal to x, then b2 is equal to 2x. All right. Then can we find b3? Yes, obviously we can find b3, because b2 is equal to twice of b2 is equal to b1 plus b3. So your b3 is going to be twice of b2, which is 4x, minus b1, which is x. So it is going to be 3x. So you have got b1, b2, b3 in terms of x. Let it be. We need to find the ratio. All right. Now Sn represents the sum of first n terms. In general notation, Sn is sum of, so Sn is nothing but b1, and S3n is what? Sum of first three n terms, that is b1 plus b2 plus b3. So that is b1 plus b2 plus b3. All right. So I'm explaining it properly. b1 is given x, and this is your x plus 2x plus 3x. So what is your answer? Then your S3n upon Sn is nothing but 6x upon x. So your answer is 6. All right, 6 is the answer. So it was pretty simple. So if you use the property, then you can write the answer within 30 seconds. Not a problem at all. 100%. All right. So easy, so smart question. All right, there's another good question. Solve it properly, then I'll discuss with you. So solve it, solve it. It's a very good question. Consider an AB whose first term is in common difference is D and Sk is the sum of first k terms and Skx upon Sx is independent of x. So just put the values and try to make it independent of x by having a relation between A and D. It's pretty straightforward, but it's still a good question. So let me write the expression at least, because that is something which you can write easily. Yes. So it is skx upon sx, and skx is nothing but kx by 2, and it is twice of the first term plus kx minus 1, number of terms minus 1 into d. Now in denominator it is x by 2, so this x is will get cancelled. So this x is not a problem, but the problem is the x written inside these brackets, x minus 1 into d. What shall we take? So this outside is k, this is not a problem. Our problem is this 2a plus kx minus 1 into d uh, divided by 2a plus x minus 1 into d. And we can't take anything. I mean, k is a constant, k is a constant, k is a constant. We need to choose a and d in such a way, a and d in such a way that this kx must get cancelled. Okay, let me rewrite this expression. Okay, if I'll rewrite, then obviously would answer it easily. So without just one more step is remaining. So try to think about it. What should be the relation between A and D, and do not try to eliminate through options. Otherwise you won't get the feel of this question. Do not try to get the eliminate by putting the values of A from the options. Okay, don't do that. Don't do that. It's a very good question, and you should do it from the expression only. So it will increase your critical thinking. I mean, application part will improve. Do not eliminate it. All right. So one more step, I'm giving you the hint. If I write 2a minus d, if I'll write like this, plus kxd. If I write 2a minus d plus xd. You can't put like say k is equal to 1. Let's take k is equal to k. You can't take 1. K, it should be true for any value of k. For k is equal to 2, it should be true. For k is equal to 3, it should be true. Because if you take k is equal to 1, then sx upon sx is obviously independent. It is 1, right? It is 1 if you take k. So it should not, you can't take you can't put any fixed value of k in this. It should be true for any value of k, all right? So that means it should be true for k is equal to 2, it should be true for k is equal to 3, right? Now see, if I put this term is equal to 0, 2a minus d. So this term will also become 0 and it will be a direct ratio of kxd upon xd. So x will get cancelled and d will also get cancelled, right? And you'll get the answer. So if 2a is equal to d, then this skx upon sx is going to be k into, this part will become 0 plus kxd divided by 0 plus xd. It is going to be k square, right? So if a is equal to 2d, then this ratio is nothing but k square. So that gives you a very important result as well. That means if your common difference is twice of the first term, if your common difference is twice of the first term, then sum of first ratio of sum of 4 n terms upon ratio of n terms is nothing but 4 square. Getting this? Ratio of first 10 n terms to ratio of first n terms is nothing but 10 square, right? So that's a very important point, all right, to observe in this. So this was a pretty good question. Now let's do this another problem of infinite GB. So this is going to be, all right, second last. Solve it fast, guys. All right, so let's write x, y, and z, and then we'll simplify it. So x, what is your x? X is nothing but a upon common ratio is 1 upon r, right? Common ratio is 1 upon r. So a upon 1 minus 1 upon r. So it is going to be AR upon R minus 1. This is your first equation. Now let's solve y. So y is now, first term is b and common ratio is minus 1 upon r. So it is 1 plus 1 upon r. So this is going to be br upon r plus 1. Pretty simple. Now let's write z. So z is c upon common ratio is 1 upon r square. So that is 1 minus 1 upon r square. A upon 1 minus r we are applying, right? So c r square upon r square minus 1. Okay. Now you can see we need to find x, y upon z. So let's multiply x, y and divide it by z. So x, y upon z is nothing but ar into br divided by r minus 1 into r plus 1, and it is c r square divided by r square minus 1. All right. So r square minus 1 will get cancelled and it is nothing but, okay, r square will also get cancelled, this r square and these two r. So it is going to be ab upon c. All right. So x, y upon z is nothing but ab upon c. So which is your correct option? A, or A is the correct option. All right. I hope it is clear. Now let's move to another one. Okay, let's do this fast. We have two problems remaining. I'll give you 1 minute for this. Only 1 minute. and then I'll discuss with you. Okay, so mod of cos x is nothing but less than 1. Why am I writing this? Because this is the common ratio of the GP written here, right? So GP, so it is 8 to the power. Sum of this GP is 1 upon 1 minus mod of cos x, alright? Can you see this GP? So let's write this sum of infinite GB, and we can write it because mod of cos is less than 1. So this is given equal to 4 cube. 4 cube. So let's write in terms of 2. 2 raised to, what is this? 3 upon 1 minus mod of cos x. Alright. This is 1. Is equal to, this is 2 raised to 6. Now compare. So it is 3 upon 1 minus mod of cos x is equal to what, 6. Alright. So we'll get 1 minus mod of cos x is equal to 1 by 2, and then we'll get cos of x mod is equal to 1 by 2 again. So that means it's like the similar equation like cos square x is equal to 1 by 2 the whole square, because we'll get cos x is equal to plus minus of 1 by 2. And you know what, okay, you need to write only values in this interval, minus pi to pi. So minus pi to pi, it's pretty simple, you can write it easily. So you're going to get 4 values, 2 here and 2 here, plus 1 by 2 and minus 1 by 2. So plus 1 by 2 is this pi by 2 minus 30, which is pi by 3. So plus minus of pi by 3. And plus minus of 2 pi by 3. Alright. Plus minus of pi by 3 and plus minus of 2 pi by 3. So this is your answer. Okay, this is minus 2 pi by 3, minus pi by 3, plus pi by 3, plus 2 pi by 3. Okay, so these four values are your answers. So I hope it is clear. Now let's do this last problem. Yeah, last one. Last problem of the day. I'll give you 1 minute to think. I told one formula in the previous lecture, and that was a very, very important formula. So if you remember it, let me remind you. You can write x raised to n minus 1 for any n. It is x minus 1 into x raised to n minus 1 plus x raised to n minus 2 plus so on up to x plus 1. So you are going to use it like x cube minus 1 can be written as x minus 1 into x square plus x plus 1. X raised to 4 minus 1 can be written as x minus 1 into x cube plus x square plus x plus 1. Yes, x raised to 4 minus 1 can be written in other form also, but we are going to use this particular form, alright. X raised to 5 minus 1 can be written as x minus 1 into x raised to 4 plus x raised to 3 and so on up to 1. I hope you have got it, got the hint. So what to do in this question? You need to. Alright. Let's multiply and divide by x minus 1 this whole expression, alright. So 1 plus x plus 1 plus x square plus x plus 1 plus x cube plus x square plus x plus 1, okay, and so on. As you take this x minus 1 inside and keep this x minus 1 in the denominator outside, it is going to be x minus 1. Then x minus 1 into x plus 1 is going to be x square minus 1. X minus 1 into x square plus x plus 1 using this formula is going to be x cube minus 1. Then x raised to 4 minus 1. Got it? Yes, got it. X raised to 4 minus 1 and so on up to infinity. Alright. So now you can club the terms in GP. How many terms we need? N terms, all right. So x plus x square plus x cube, these are forming in GB, x raised to n, plus minus 1 minus 1 minus 1, n times it is n, right? Now write the sum of this GB. So it is going to be first term into number common ratio to the power number of terms divided minus 1 divided by x minus 1 and minus n as it is, okay? So this is going to be your answer. You can take the LCM. So after taking the LCM, you can write your answer as x into x raised to n minus 1 minus n times of x minus 1 divided by, now it will become x minus 1 the whole square. So which option is correct? Oh, so this is actually the same thing. Just take minus common, and C will be the answer, all right? So C is just take minus common from the numerator and the same, all right? So I hope it is clear. So this was the practice session for AP and GB, and we'll continue. We'll continue HP from the next session. So I'll discuss nth term, general term of HP, properties of HP. After that, AM, GM, HM, and in this sequence, we'll finish sequence and series. All right. So thank you very much for watching this, and subscribe the channel. Let's Crack JEE, and we are going to cover everything in this. All right. And use my code JEET1 if you are getting subscription on Unacademy Plus, where India's top educators are teaching every day live. All right. So I have told multiple times that this is a very good opportunity to take to start your preparation with Unacademy. All right. Thank you very much.